Today we are exploring an agent-based model that investigates how fraud spreads or is contained within peer networks through the influence of descriptive norms. The model builds on the fraud triangle theory, showing how individual behavior is shaped by motivation, opportunity, and attitude, while also accounting for the social information agents receive from their surroundings. So, before we start, could you please introduce yourself?
Sure. Thank you for having us today. My name is Alexandra Eckert. I'm a research associate at the Institute of Management, Accounting and Simulation at the Hamburg University of Technology.
Also, hello from me. My name is Christian Stinn, and I'm also a research associate and a PhD student at the Institute of Management, Accounting and Simulation at the Hamburg University of Technology.
To begin, what's the main purpose of this model? What key aspects of fraud behavior are you trying to understand, and how does the model address the influence of social norms?
Basically, our model deals with fraud in organizations. So we have several statistics that show that organizations face different kinds of fraud internally, and that's what we are basically looking at in our model. So one of the question is um, to understand how fraud can spread or be contained in an organization via a descriptive norm mechanism. On the other hand, the statistics also show that we have different kinds of frequencies for different kinds of fraud categories. For example, the ACFE reports on occupational fraud show that asset misappropriation, so stealing from the company, is much more frequent than, for example, financial statement fraud. And we would like to see how we can explain these differences in frequency building on the descriptive norm mechanism. So is there a possibility to explain how the descriptive norm mechanism can lead to this outcome that I show here on the slide? And you already introduced the fraud triangle framework, but in my explanation now, I will just focus on the social signaling aspects that we introduced in our model. This builds on the definition of social norms and descriptive norms by Christina Becchieri. And here on my slide, I show the main aspects that we use in our models. So you already said that people receive social signals from others. This could be comments. These could also be reports, for example, especially within the company. There are a lot of reports. Also, but this is less important in our model, is social feedback, like I like what you do or I dislike what you do. And from there, essential parameters that we use in our model is, on the one hand, empirical expectations. So this is basically saying what others do in the given situation and what I think others do in this given situation. And also, we use the concept of norm sensitivity to introduce a kind of threshold in our model. So we think that norm sensitivity stands for how many relevant others are needed to change the behavior of an individual person. So this is our basic framework in short. And how we implement this is that we make agents interact with one another, and agents build their empirical expectation based on what they see others do in our simulation. And then they compare this empirical expectation against their personal threshold, which is the norm sensitivity. And if we now look at our model, we see here that we populated our model with empirical norm sensitivity distribution. So we measured norm sensitivities. And on the left-hand side, and I try to show this to you here. So on the left-hand side, we have a chooser where you can choose which kind of norm sensitivity distribution you would like to populate your initial population with. And when you run the model, you see that people turn either green, which stands for an honest person, or they turn red. This is the fraudulent population. And here in this John norm sensitivity distribution case, we see that most people turn fraudsters within a short period of time. And we can see here the sensitivity distribution that was selected in the model, and also what is the average number of fraudsters in this simulation setting. We also have a second norm sensitivity distribution, which we call LoRa. We measured this using a vignette study, and here we see that the norm sensitivity distribution that the model was populated with differs only very slightly from the previous norm sensitivity distribution, but we see that the average number of frauds that come out of the simulation is much lower. So, we think that with this model, we addressed the two questions that I mentioned in the very beginning.
What were the main difficulties in building this model? Was it challenging to simulate how people update their beliefs based on distorted or accurate social information?
The implementation itself was not so difficult, let's say. We think that we found a good way to do this. There are already existing threshold models that we could build on. I think the main point or that we were struggling with was much more of a methodological nature, especially when it came to the model specification and calibration. So we wanted to measure empirical norm sensitivity distributions, and here we found that it was difficult to overcome preferences in certain disciplines. I think agent-based modeling is interdisciplinary in nature. Still, we have the disciplines that we would like to present our models to, and they have different preferences for different methodologies. And so the way we measure our empirical norm sensitivity distributions was accepted in the one community, but rejected by the other. So we had some difficulties here in bridging this divide.
As for the results, what kinds of behaviors did the model reveal? Did anything surprise you about how fraud spread or declined depending on how agents perceive their peers?
Yes, good question. Maybe. So we saw that small differences in norm sensitivity distributions can have markedly opposite effects on the organizational resilience to occupational fraud. And it's not just about the mean values of norm sensitivities, but it's about the exact distribution within an organization. And agent-based modeling is like a virtual laboratory, so we can also see under what conditions, for example, different norm sensitivities or different networks or information biases, under what conditions or what conditions lead to tipping points or changes in fraudulent activities. And maybe one also interesting point from the theory development or formalization perspective. So in social science theories, some parts are not fully explained, and it was quite interesting for us to clarify some mechanisms that we had to implement, but are not fully explained in the theory itself. So, for example, based on our implementation, we also thought about if there's also a need for a different norm sensitivity that would measure how many people do I need that expect me to do something and not is doing something. So that are maybe our main insights from this project.
This model is available on comsys.net. Did you face any issues in making the model, accessible and especially, understandable and usable for others using comsys.net?
First of all, we really appreciate that COMSIS is there as an archive where we can upload our models. And in general, there are not much difficulties in using the database. And for us, there are two benefits of model sharing. So one is that we can make our implementation available to others, and the other one is to provide transparency about our model implementation. And the main challenges that we faced was actually the documentation effort, because we had to go much into detail and to question our own implementation. How do we explain it? How do we translate this? And to evaluate if there's also other ways of implementing specific mechanisms, for example. But the good news that we found is that there are already scientific standards, for example, the ODD protocol, that we could use as a helpful scientific guidance to make or to create this transparency about our model and to get this discourse about our model running, basically.
What's next for this model? Are you planning to test new scenarios, or like add more real world data or explore different kinds of networks or fraud types?
Yes, so at the moment we are working on different model extensions, you could say. So, for example, to study the role of, as you said, network structures, for example, hierarchies. And we also try to investigate different anti-fraud interventions. At the moment, we only implemented like the social mechanisms, but not really the interventions. And we are also conducting a systematic literature review on other studies that formalize Bucheri's social norm theory, because we found that there are so many different implementations, and we want to give an overview or maybe a guideline to other modelers and researchers. And last but not least, we are also trying to improve our empirical measurement of non-sensitivities. This is the next step. Yeah.
Thank you. Thank you very much for joining me.
Thank you for having us.